2 more lessons to go for the rest of the year. Next to last one here is on conditional probability. Given that A and B are dependent events, and we've talked a little bit about this if they're independent events, but if they're dependent events, the conditional probability of an event B, given that event A has already occurred, is defined as, and we write it this way, the probability of B occurring given that A has already occurred. And we calculate this by finding the probability of A and B divided by the probability of A. And of course, the probability of A has to be something besides 0. So let's take a look at some examples. Kim draws a card from a standard 52 card deck. What is the probability that she draws a heart given that the card is from a red suit? Well, there are 26 red cards in the deck. There are 13 hearts. If A is the event where she draws the red card, and that's the given part, event B would be that she drew a heart. Well, the probability of A, and that's the bottom one, is 26 over 52. There's 26 red cards, so given that we've drawn a red card half of the time, what's the probability that it is a heart? There are 13 hearts in the deck of cards, and so this is 1/2 and 1/4, and it's going to be 1/2 divided by 1/4. And here they finish up the problem. And again, here's the formula that we're dealing with. Probability of getting B once A has already occurred, and here's the probability of A and B, which we found to be 1/4, divided by the probability of A, which we found to be 1/2, and 1/4 divided by 1/2 is 1/2. And just to show you how that works, we're going to take 1/4 and divide it by 1/2, and of course we would change that to 1/4 times 2 over 1, copy, change, flip, and that would give us 2 over 4, which is 1/2. So just giving you a little exercise, a little extra practice on dealing with fractions. Next problem, Vitali draws a card from a standard 52 card deck. What is the probability that she draws a jack given that the card that she drew is a face card? And of course there are 12 out of the 52 cards are face cards, and 4 of those 52 are jacks. And changing this from a vertical problem to a horizontal problem, this would be 4 over 52 divided by 12 over 52, which, when you change the multiplication problem, is 4 over 52 times 52 over 12. Do a little cross-canceling there, and I get 4 over 12, which is 1/3. Now, I do want you to make note that this little circle is running a little bit below what the answer is, because the last question is way below, so I just want to make sure you understood that. Next example, find the probability that a student plans to attend college after high school if the student is a girl. So we first of all have to figure out the number of girls, and if I add this column right here, I get 514. So there are 514 girls. There are, if I add all of these up, there are 1,000 students, 1,007 students. So 514 of the 1,007 students are girls. And what is the probability that she's going to attend college? That would be 376 over 1,007. And we'll continue the computation on the next page. And here that is. You can see how they got their 1,007, adding those all up. And we're going to take the probability of A and G, which is the 376 over 1,000, and divide it by the probability of it being a girl, and which was 514 over 1,007. And I'm betting you have begun to see the little shortcut here. If I take this and I flip the second one over, the 1,007s are going to cancel, and the 514 is going to remain on the bottom. So this is 376 over 514, which reduces to be 188 over 257, which is 0.732, which is about 73%. And here we have those same 1,007 students, and this time we're trying to find the probability that a student does not plan to attend college after high school if the student is a boy. So the ones that plan on not attending high school, all right, are these right here. The boys that are not going to college would be 151 over the 1,007. Divided by all of the students that are boys, which, and if I add these together here, is 493, so that'd be 493 over 1,007, which shortcut 151 over 493, which is 0.306, which is 30.6%. Here we have a total of 1,180 students, and we want to find the probability that a student is non-varsity given that he or she is a senior. So the probability that he is a senior that is non-varsity is 257. That's these right here, and so that'll be 257 over 1,180 divided by, and now we want to look at all of the students that are seniors, and there are a total of 308 of those. So this is 257 over 1,180 divided by 308 divided by 1,180, which is 257 over 308, which is approximately 0.834, which is 83.4%. And you can see the circle's gotten actually so low it's actually dropped off. In this case, the answer is D. And one last final example. Here we want to find the probability that a student is varsity given that he or she is a sophomore. Well, as it turns out, there are 284 sophomores, right, out of a total of 1,180 students, and 22 of those 1,180 students are varsity sophomore players, and we'll divide that by 1,180. Shortcut 22 over 284, which is approximately 0.077, which is 7.7%. There's that red circle that I told you was going to be a lot lower than it should be. The answer, of course, here is C. As usual, if you got any questions, problems, please Edmodo me, call me, text me, email me, post something for me if you have any questions. And of course, if you did watch it and you understood it, all right, make sure that you let me know that. If you watched it and didn't understand it, please don't just say you watched it. Tell me what part you didn't understand, what was confusing, so I can make sure that I emphasize that or make sure that it gets talked about tomorrow. One more new lesson, one more video, and the year is over.